Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Normalization and Denormalization. Normalization and denormalization are fundamental concepts in data modeling and design, playing a crucial role in the structure and efficiency of relational databases. At their core, these processes aim to optimize database performance and integrity, albeit in different ways. Normalization focuses on reducing redundancy and improving data integrity, while denormalization aims to enhance read performance by reducing the need for complex joins. Normalization is the process of organizing data to minimize redundancy and dependency. It involves dividing a database into two or more tables and defining relationships between the tables. The primary objective is to isolate data so that additions, deletions, and modifications of a field can be made in just one table and then propagated through the rest of the database via defined relationships. The process is typically done in several stages, known as normal forms. Each normal form has specific requirements that must be met for a database to be considered normalized to that level. The first normal form eliminates repeating groups by ensuring that each field contains only atomic values and each record is unique. This means that there are no arrays or lists within a field. Each field must contain only one value. For instance, consider a table where a customer can have multiple phone numbers stored in a single field. To achieve one NF, you would need to create a separate record for each phone number or a separate table to store phone numbers with a foreign key reference to the customer. The second normal form builds on the first by removing subsets of data that apply to multiple rows of a table and placing them in separate tables. It also ensures that all non-key attributes are fully functionally dependent on the primary key. This means eliminating partial dependencies, where a non-key attribute is dependent on only part of a composite key. For example, in a table where the primary key is a combination of student ID and course ID, attributes like course name should be placed in a separate table because course name depends only on course ID and not on student ID. The third normal form goes a step further by ensuring that all the attributes in a table are only dependent on the primary key. This eliminates transitive dependencies, where non-key attributes depend on other non-key attributes. For instance, if a table contains student ID, advisor ID, and advisor name depends on advisor ID, then advisor name should be moved to a separate table where advisor ID is the primary key. Voice code normal form is a stricter version of 3NF. It deals with situations where 3NF is not sufficient to ensure data integrity. A table is in BCNF if it is in 3NF, and every determinant is a candidate key. A determinant is any attribute on which some other attribute is fully functionally dependent. For example, if a table has attributes student ID, course ID, and instructor ID determines course ID, then instructor ID should be a candidate key. Normalization has several benefits. It minimizes redundancy, which in turn saves storage space and improves data integrity. By breaking down tables into smaller, related tables, normalization ensures that updates are easier and more efficient, reducing the chances of anomalies. For example, if a student's address changes, the update only needs to be made in one place rather than in multiple records. Additionally, normalized databases are easier to understand and maintain, as the data is logically organized. However, normalization also has its drawbacks. One significant disadvantage is that it can lead to complex queries and joins, which can negatively impact read performance. Every time data is read from a normalized database, multiple tables might need to be joined, which can be computationally expensive and slow. This is where denormalization comes into play. Denormalization is the process of merging tables to reduce the number of joins needed to retrieve data. It involves combining data from related tables into a single table to optimize read performance. While this can lead to some redundancy, the trade-off is often worth it in scenarios where read performance is critical, such as in reporting databases or data warehouses. Denormalization can take various forms, such as adding redundant columns, creating summary tables, or even duplicating entire tables. For example, to reduce the number of joins needed to retrieve customer orders, a denormalized table might include customer information alongside order details, even though this information could be stored in separate normalized tables. The primary advantage of denormalization is improved read performance. By reducing the number of joins required, data retrieval becomes faster and more efficient. This is particularly important in applications where read operations are more frequent than write operations, such as in online analytical processing systems. Denormalization can also simplify complex queries, making the database easier to use for end users who may not be familiar with SQL or relational database design. However, denormalization also has its downsides. The most significant drawback is the introduction of redundancy, which can lead to data anomalies and increased storage requirements. For instance, if customer information is stored alongside every order, any changes to the customer's details need to be updated in multiple places, increasing the risk of inconsistencies. Additionally, denormalized databases can be more challenging to maintain, as the logic for ensuring data integrity often needs to be handled at the application level rather than by the database itself. In practice, the decision to normalize or denormalize a database often depends on the specific requirements and constraints of the application. For instance, transactional databases, which require frequent updates and ensure data integrity, are typically normalized to reduce redundancy and avoid anomalies. On the other hand, databases designed for reporting and analysis, where read performance is paramount, might be denormalized to optimize query performance. A balanced approach is often the best solution, combining elements of both normalization and denormalization to meet the specific needs of the application. For example, a database might be normalized to 3NF to ensure data integrity, and then selectively denormalized in certain areas to improve read performance. This approach allows for the benefits of both techniques while mitigating their respective drawbacks. The concepts of normalization and denormalization are essential for any data management professional to master, as they directly impact the design, performance, and maintainability of relational databases. Understanding when and how to apply these techniques is crucial for optimizing database performance and ensuring data integrity. In the context of the Certified Data Management Professional Associate certification, a deep understanding of these concepts will enable candidates to design effective and efficient database systems that meet the needs of modern applications. Normalization and denormalization are not just theoretical concepts, but practical tools that can significantly impact the performance and usability of databases. By mastering these techniques, data management professionals can create robust, scalable, and efficient database systems that support the needs of their organizations and users. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UExcel, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.